Welcome to Math with Millie
and Ziggy.
Yes, and Ziggy. Okay, Ziggy, today we're going to be talking about the Pythagorean theorem. Did you know that the longest side of a right triangle is called a hypotenuse?
Hypotenuse? Are we eating a plant?
No. Hypotenuse. The other sides are called legs.
Run away. No, come back. We need you.
We can draw a square right on top of the hypotenuse, right here.
Oh, that's heavy.
So since it's a square that we put on that side, that means each side of this square is equal, right?
Yeah, I trust you.
So how do we find the area of a square? Do you remember?
Isn't the area of a square, isn't it one of the sides squared like times itself?
Yes. Great job, Ziggy. So how you find the area of a square is to square one of its sides, or in other words, times itself. So let's say the hypotenuse is 5. So that means if we put a square on the hypotenuse,
Oh, that's heavy.
then we can figure out the area of that square, right?
You're talking gibberish. No me entiendo, chiquito.
We know one side of the square is 5, right?
Yeah.
And since this is a square, that means all sides are the same, right?
Yeah.
So that means we just take one side length
5.
and we multiply it times itself.
Oh.
So 5 times itself, 5. So 5 times 5 equals...
25. Yes.
So this is where the Pythagorean theorem comes in.
What?
The Pythagorean theorem.
Oh, what? Are we dealing with snakes now? You bringing pythons into math? They give us dangerous hugs of death.
No.
I don't want them here.
Calm down, Ziggy. We're not talking about pythons. We're talking about the Pythagorean theorem.
Oh, what is that?
Okay, I'm going to tell you. But first, you need to take a deep breath and relax because you're getting really out of control here.
Okay, I'm relaxed. Breathing in and out.
It might be a little complicated.
All is cool and collective.
The Pythagorean theorem states that the area of the square drawn on the hypotenuse of a right triangle equals the sum of the areas of the other squares.
The python's attacking me. I can't breathe. What are you saying?
Ziggy, calm down. Let me explain. I'll say it again slowly, and I'll even draw you a picture.
Okay.
Here.
Okay.
The Pythagorean theorem states that the area of the square drawn on the hypotenuse
It's heavy.
of a right triangle equals the sum of the areas of the other squares drawn on the legs of the triangle. So in other words, you find the areas of the squares on the legs and you add them together.
I'm gonna faint.
Wake up, Ziggy.
Huh? Oh, okay.
Let's just do an example. That might help.
Yeah. Okay.
So let's look at this same triangle. The hypotenuse length, that one side there, that is 5, right?
Okay.
And we squared the box that we put on top of it.
Oh, it's heavy.
So 5 times 5, we get 25. So we know the area of this square on the hypotenuse is 25, right?
Yeah.
Okay.
Yeah, I get that part. I
So
understand
let's
that.
put squares on the other areas of the triangle. So we have these legs
Don't
of the
run
triangle.
away.
So here's a square here, and here's another square there.
Okay.
So the length of one of these legs is 3, and the other leg is 4. So let's find the areas of these two squares. Now, how do we find the area of a square again?
Area of a square. It's one of the sides squared, so it's times itself.
Yes. Yes, great job, Ziggy. So what is 3 times itself? 3 times 3.
9. Easy peasy.
Okay, so the area of this square on this leg is 9. Now let's look at the other leg. Its length is 4. So the square on it has a length, one of its sides is 4. So how do we find its area? How do we find the area of this square?
It's a square side squared.
That's right.
You times
so
it times itself.
4 times 4 is
16. Okay, now what? We have the area on all the squares. What do we do now?
So remember,
I don't get it.
the Pythagorean theorem states that the area of the square that's drawn on the hypotenuse of a right triangle equals the sum of the areas of the other squares drawn on the legs. So in other words, you find the areas of the squares on the legs and you add them together, and that will equal the area of the square on the hypotenuse.
Okay, so you're saying if I add up the area of these two leg squares, 9 and 16, that will give me the area of the hypotenuse square?
Yes, exactly. You got it, Ziggy. You figured it out. So let's see if it works.
Okay. So the area of this leg is 9 and the area of this leg is 16. If we add them together, the answer is 25. It's 25.
Yes, right. So the area of the largest square equals the sum of the areas of the leg squares.
Oh, yay. I figured
Okay,
it out.
that is correct. So you did awesome, Ziggy. But wait a minute.
Woohoo!
Wait a minute. What if
I don't like what ifs.
What if we don't know the length of the hypotenuse?
What you're saying, there's a triangle where we know the legs, but we, don't run away, but we don't know what the hypotenuse is?
That is right.
Is that what you're saying?
So here we have a right triangle, and one leg is 6 length, and the other leg is 8 length. But the hypotenuse, we don't know what it is, so we'll just call it C. We don't know.
How in the world are we going to sort out the shenanigans?
Well, first let's draw a square on each of
Okay,
these sides,
okay.
okay? And since we know the lengths of the legs, we can find the area of those two squares. Do you remember how?
Area. Okay. The area of a square is, one side
That's
times
right.
itself. One side squared.
So, if one side is 6, then it would be 6 times
6.
6,
It's 36. So that's the area of that square.
Right. And the other leg length is 8.
Okay. So the area would be one side times itself. So 8 times 8. 8 squared. That's 64.
Right. So we have the areas of these leg squares. Congratulations. 36 and 64.
Okay, but now what? What do we do?
Well, do you remember the Pythagorean theorem?
Yeah, something like blah 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 blah.
No,
blah,
Ziggy.
blah.
It states the areas
What?
of the squares on the legs added up equal the area of the hypotenuse square. Remember?
Blah 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 blah.
Just trust me, Ziggy, okay? So let's add up the areas of these square legs.
Okay, so 36 plus 64. That's 100.
Right.
100.
So let's write that out.
Okay.
36 centimeters squared
Squared.
plus 64 centimeters squared.
Squared.
Right? That's the area of those two sides.
Yeah.
Equals 100 centimeters squared,
But
right?
that doesn't help us know the length of the hypotenuse. We just have the area of that stupid box thing laying on it. It's super heavy.
Well, if we know the area of that square that's on the hypotenuse, we know that the area of that square is 100 centimeters squared. So then what must each side of that square be?
You're taunting me. I have no idea. Don't pick on me. I have feelings, even though I'm
Yeah.
just a rabbit.
Z, I'm sorry. Okay, let me ask you this way.
What?
Do you remember how to find the area of a square?
Why, yes, I do, Millie. How kind of you to ask. It's one side squared.
Okay. So then if we know that one side squared equals 100, how could we find out that one of the sides, like what one of the sides would be?
So what you're saying is 100 is the area,
Yes.
and now we have to squaring one side. That's what area is. In other words, one side times itself.
Right.
So wait a minute. Hold the presses. If the area is 100, that means we had to multiply something times itself to get 100.
Correct.
So wouldn't we just do the square root of 100? I mean, after all, the square root of this answer, yeah, okay, would mean we multiply it times itself to get 100. So the square root of 100 is 10.
Yes, exactly. You got it, Ziggy.
All right, time to celebrate! Woohoo! Life is good. Yes, I'm gonna party until it's 1999.
Wait,
Yeah.
wait.
What?
What if
No, not this again.
instead of not knowing the hypotenuse, we don't know what one of the legs is?
Why do you do that?
Do what?
Mess with my vibe, dude. I don't mess with yours.
Well, we need to know these things for math.
Okay, fine. Let's just get this over with.
Okay. Let's say we have a right triangle and the hypotenuse is 13 and one of the legs is 12.
12, okay.
But we don't know the length of this side here, okay? Now, do you remember the steps that we do?
Okay, so number 1, we draw squares on the sides.
Yes.
Then we find the areas of the squares that we can.
Yes.
So 13 times itself, I need a calculator, 169 inches squared. 12 times itself, that's 144 inches squared. Then the Pythagorean theorem says the sum of the areas of the legs equals the area of the hypotenuse, right?
Correct.
So we have 144 inches squared, and the other is a A2. We don't know what it is yet. So we'll write the equation.
Okay. Keep going.
We're going to add the areas of the leg squares to equal the area of the hypotenuse square.
Correct.
So 144 inches squared plus, well, we don't know what A is, so A squared equals 169 inches squared.
Did I do it?
So now we have a stupid equation that I don't know how to do.
Okay. Okay, so do you remember how when there's a letter in an equation and there's an equal sign, we got to get the stinky letter by itself?
Oh, yeah, the stinky letter.
So that's what we got to do here.
Okay.
So how do we get that stinky letter by itself?
Well, that 144 inches squared needs to go.
Right. So we have to subtract it on this side of the equals,
Okay.
which means what we do to one side, we do to the other.
other.
Right. So we subtract 144 inches squared from 169 inches squared. And what do we get?
25 inches squared.
Right.
So that means that the hypotenuse A is 25 inches squared.
I know.
We
No,
did
no,
it.
no, 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 not yet,
What?
Ziggy. Remember, the Pythagorean theorem states that the areas of the leg squares on them added together equals what? Do you remember what it equals?
Oh, the area of the square on the hypotenuse. Ooh, it's heavy. Ooh.
Right. So if the answer is 25 inches squared for the area of that square on the hypotenuse, how are we going to find the length of one of those of one of the sides of that square?
Oh, okay. So you're asking what times itself equals 25?
Yes.
So we need to do the square root of 25.
Right.
So that's that's 5.
Right.
5. A equals 5 inches.
Good job, Ziggy. So the bottom line is this, Ziggy. Are you listening?
Sorta.
Okay, the sum of the squares of the legs
Run away.
equals the square of the hypotenuse. And this Pythagorean theorem applies to all right triangles and only right triangles.
That sounds a little prejudiced.
It's just the right one. So
Okay.
that means it has to be 90 degrees, okay?
90 degrees.
So if we have a right triangle that has 90 degrees angle in it, and it has 3 sides, A, B, and C is the hypotenuse,
C is the
then we
hypotenuse,
could say the squares created on these sides
the legs.
would be like this.
Okay, yeah.
Let's see. It would be A2 for the area of that square on that leg side.
Okay, A2.
And
the area.
B2 for the area of that square on that leg
area.
side.
Okay, that's square.
And C squared for the area
The area.
on that square box on the long hypotenuse side.
Okay. Okay.
So, I mean, the easiest way to write this equation, Ziggy, is this. A squared plus B squared equals C squared.
I think my mind just exploded.
So just remember, the Pythagorean theorem applies to only right triangles. Only right ones.
Right ones.
So what if the sum of the squares of the legs doesn't equal the square of the hypotenuse long side? Do you know, Ziggy?
Then it isn't a right triangle.
Right. It is not a right triangle.
Too bad you weren't right. You must be wrong. Boo, boo.
Good job. So we hope you enjoyed this episode, and we'll see you next time. We really enjoyed doing math with you.
Yes, we did.
It's time for a nap.